There are four varieties of linked list. These are: first, singly linked list, or this is called also in short singly list. The second is called circularly linked list, or in short circular list. The third is called doubly linked list, or in short called doubly list. And the fourth is called doubly linked circular list, or simply called doubly circular list. So singly linked lists are called singly list, circularly linked lists are called circular list, doubly linked list or also called doubly list, and the doubly linked circular list or also called doubly circular list. Say for example, we have a list of elements A, B, C, and D. If this list is implemented as a singly linked list of four elements, then in a singly linked list, there will be four nodes, okay? Because there are four elements. These four nodes contain elements. The first node contains A, the second node contains B, and the third node contains the element C, and the fourth node contains element D. The pointer of the first node points to the second node containing B, and the pointer of the second node points to the third node containing C, and the pointer of the third node points to the fourth node. And the pointer of the fourth node being the last element, this is null. Now, a singly linked list may have a head node or without a head node. If it has a head node, then we have what we call here the head node, and it has also two parts. This part here is the element containing the element, and since it is a head node, it doesn't have any element there, and its pointer points to the first node. Okay, the first node is this containing the first element. The second node is this one containing the second element, and so on. And this is the fourth node containing the fourth element. So again, a singly linked list may have a head node, which is this. The head node is not part of the elements. It is simply a beginning marker. It simply acts as a beginning marker of the singly linked list. It's like a door to the singly linked list. And the pointer of the head node points to the first node containing the first element. So again, the head node is not part of the elements of the linked list. It is simply a pointer to the first node of the singly linked list. But not all singly linked list has head node. It's possible that a singly linked list will have no head nodes. So in that case, if it has no head node, then the first node is the beginning marker of the singly linked list. If this list is a circularly linked list or circular list, then this part here, the pointer of the last node, which is this one here, points back to the first node. Okay, so this is now a circularly linked list or circular list without a head node. If it has a head node, then we could put in here a head node as having no elements, and the pointer of this points to that, and we call this the head node. And so this last node pointer will be pointing to the head node. Okay, so if the circularly linked list has a head node, then the pointer of the last node in the list points back to the head node. If it has no head node, then the pointer of the last element or the last node points to the first node because it has no head node. So this is now a circularly linked list. How do you know that a linked list is a circularly linked list or a circular list? If the last node. Say for example, we call this last. If last dot, okay, this is our Python class implementation for a singly linked list node. Okay, so we call this part here value, the field value, and the second field is next node. So this is next node. This is value. This is next node. This is value, and this is next node. And this one is value. This is next node. Each node is defined as a class having two fields, and these field names are value and next node. So think of this init method, initializer method, as the class constructor, so that when you instantiate this class, creating an instance, say for example L1 node A. So L1 is a new node having element A. Okay, so this is your L1, which is an instance of node having two fields. The first field is value, and the second field is next node. Okay, so you refer to this as L1 dot value, and this one as L1 dot next node. Okay, so again, you refer to this as L1 dot value, and this one as L1 dot next node. So again, back to that question, how do you know that a linked list is circular linked list or circular list? If this node, the last node, is called last, if we check last dot next node, if it is equal to, say for example, if it has a head node and the head node is called head, okay, if that is true, that the last, this one, last node dot next node, which is this one, is equal to head, meaning this one points to head, this one points to head. Okay, if it has no head node, say for example there is no head node and this one points to the first node, to A, then say we call this, say we call the first node as first. So if last that next node is equal to first, okay, first is the first node containing the first element A. Again, so this is the condition that will hold true if the linked list is circular. This will be the condition that will be true if it is a circular linked list with a head node, where head is the head node. Now, what if the list A, B, C, D is a doubly linked list or a doubly list? It would look like this. It has 4 nodes where each node is having 3 fields. Okay, so this is the Python implementation of a doubly linked list node. So for singly linked list, the node has only one pointer. Okay, this one. This is the only pointer for the singly linked list or the circularly linked list. For doubly linked list or the doubly linked circular list, the node of the doubly linked list has 2 pointers. We have a left pointer and this is right pointer. Okay, please correct this one. This is self dot right. Okay, so since this is now doubly linked list or doubly list, this has 3 fields, and take note that the value here could be 1 or more. In our example, I just use 1 element value, but it could be more. Like for example, if that node is a student record, so it will have class stud rec, then there will be several fields, right? You have the ID, the name, the course, the year level, and so many others. And then we have the left and the right pointers. So these are the pointers. Now this one here, the value may also be one or more, okay, depending on what record this node is representing. So say our doubly linked list node has only one field element and the two other fields are the left and the right pointers. So the first node, this will be the left field and this is the right field and this is the value. So it has three fields. The first is left, the second is value, and the third is right. So this is also 3. Okay, this is the left pointer, the right pointer, the left pointer, and the right pointer. So if this is the first node, then the value here is element A, the first element in the list. And this one is B, C, and this is D. Okay, this one being the second node, this is the third node, and this is the fourth node. Now, the right pointer of each node points to the right side element. So this one points to B, and the left pointer of B points to the left element. Now, since A has no left element, because it is the first node, then the left pointer of A is null. It's not pointing to another node, which means that this is the first node. Okay? How do you know that in a doubly linked list, that node is the first node? If the left pointer is null. Okay? So if node dot left is equal to null, okay, or if this is Python language, you would say none. If that is true, then this node here is the first node. If the left and the right pointers of a node points to some elements or some valid memory addresses, then that node is not the first node and it's not also the last node. So it's a middle node, somewhere in the middle. And the right pointer of B points to C and the left pointer of C points to B. The right pointer of C points to D and the left pointer of D points to C. And the right pointer of D being the last node, this is the last node, this is null also. So how do you know that this is the last node? If the right pointer is equal to none. Okay, if this is Python programming language. Okay, if that is true, then this node is the last node. What if this is a doubly linked circular list? If it's a doubly linked circular list, if the list with elements A, B, C, D is a doubly linked list, then it's the same as this except that the left pointer of the first node, now by the way, a doubly linked list or doubly list may also have a head node. If the doubly linked list has a head node, then this is the head node. The value is no element, and the right pointer points to the first node. Okay, say this is the head node, and the left pointer of the first node points to the head node. And the left pointer of the head node is null. Okay, so this is now a doubly linked list with head node. If this is doubly linked circular list with head node, then the right pointer of D points back to the head node and the left pointer of the head node points to the last node. So this is now a doubly linked circular list with head node. If without head node, it would look like this. Without head node, the right pointer of D points to the first node because there is no head node, and the left pointer of the first node points to the last node. Okay, so that is now a doubly linked circular list without head node. In the previous video, I already discussed with you how insertion and deletion is performed in a singly linked list. This time, I will show you how to insert and delete nodes from a doubly linked list. And it's the same for doubly linked circular list, except if you're going to delete the first node and the last node, then there will be some difference in the code. But if it's in the middle, if you delete from the middle, it's the same with the code for insertion and deletion is the same for both the doubly linked list and the doubly linked circular list. So say for example, we're going to insert a new node with element E at the position of B. So we're going to instantiate this one. So we would say new node gets node. Okay, I'm referring to this node here because it is doubly linked list node, say for example E. Okay, so the value of this new node, which is this, is E. So this is new node and this is value. This is the right pointer and the left pointer. Value here, due to that when this statement is executed, that value of the new node, this one, is E, and the left pointer and the right pointer are initialized to none or null. And then, how do we make this the second node? Currently, this is the first node, this is the second node, and this is the third, and this is the last. How do you make this one the second node and be the third node and this one the fourth and this one the fifth? Okay, you want this to become the second and this would become the third, the fourth, and the fifth after you have inserted the new node with new element E. So to insert E, what we're going to do is, say we delete this, you need to make this one to point to B. Okay, so you would say new node dot right gets, say the name of this node is first and the name of this node is last. Say the only two nodes that has names are the first node with the name first and the last node with the name last. So you would say new node dot right, which is this, gets, what is this? This is first dot right. So this is equal to first dot right. So this one, which is this, points to where first dot right is pointing. This is your first dot right. So since this pointer points there, this will be pointing also on that same node that this pointer is pointing to. So if this is memory address 72, say the memory address of this is 72, okay, that's why it is pointing there. This will become 72 also, right? Due to this statement that the first dot right, which is memory address 72, is assigned to this, okay, to first dot right. So these are memory addresses, 72. So this one will also be pointing on that memory location since this one is pointing to that memory location. So this is how you are going to make this to point to the second, to the node containing B. And then we make this to point to A. So you would say new node dot left, referring to this, gets first. Okay, so this is first, so this one points to A. And then next we need to make this to point to new node. So you would say, but first you need to make this to point first before you move this one, because we reference this node via this link. If you cut this, there's no way for us to, we could not reference this anymore via this pointers. Make this to point to new nodes. So we would say, what is this pointer? Using first as the reference, we would say first dot right. First dot right is this one, which is this node, and the dot left of that is this one, this pointer here, the left pointer of the node containing B. Okay, so this one is referenced as that. First dot right, dot left gets, or we want this to be redirected to point to new node. So this is now pointing on new node. And then make this to point to new node. So we call this first dot right. So the first dot right, which is this, we cut that, we redirect it to point to new node. So first dot right gets new node. Okay, to do that, you have to execute this. So this one, the first statement is to point this one. Okay, the first statement here, this one, makes this to point there. And then the second statement here, which is this, makes this one to point there. And then the third statement here makes this one to point to new node. And then the fourth statement here makes this one to point to the new node. So it takes 4 statements, or it takes to redirect 4 pointers. So 4 pointers need to be redirected. And these are our way of redirecting the 4 pointers. So with these redirections, how is your doubly linked list look like now? What is the resulting doubly linked list now? Say if this is the first node, the second node, the third node, the fourth node, and the fifth node. There are now 5 nodes, right? So this is A. From A, the right pointer of A, okay, this is the first node with element A. The right pointer of A points now to this new node having element E. So this is E. A is pointing there. And the left node of this new node points back to A. So left points there. And the right pointer of E points to B. So this is now B. And the left pointer of B points to new node. So this one points there. And then all the rest are the same. B points to C. The left pointer of C points to B. And the right pointer of C points to D. And the left pointer of D points to C. And this is null. Okay? If that is not circular. But if it is circular, then it's the same. This one, the right points there. And this one points here. Okay? So we have already inserted this new node having new element E as the second node. So from A, this is now the first node. This is the second node. This will be the third node, the fourth node, and the fifth node. Now if we're going to delete this time, say we want to delete this node, the second node containing the second element B, then how are we going to do that? To delete this, all we have to do is to make this right pointer of A to point to C and the left pointer of C to point to A. So you need only to redirect 2 pointers. Okay, this pointer and that pointer. You don't need to redirect the left and the right pointers of the node you are going to delete, the second node. So how are we going to do this? If, say for example, this is labeled as first, as the first node, and this one is labeled as last, then let's first redirect this one because we reference this via the first node. We usually use the first node, or if it has a head node, to reference all the elements inside the list. So what do we call to this left pointer of C using first? It would be first dot right, this one, first dot right is this, referring to this node, and then the dot right of that is this one, referring to this third node, because this one is pointing there to this node, so this one is equal to that. So first dot right refers to the third node. Okay, this refers to the third node, which is this pointer. First dot right is this one. The first dot right refers to this one, which is this node because it is pointing there. And then the dot right of that is this one. Okay, this is the second node. Dot right of that is this one, this pointer, which is equal to that node, letter C. And then the left of that, so this one now is referring to the third node, and then the third node, dot left. This is now referring to this pointer. Okay, so the whole expression here refers to this pointer. And we want to redirect this to point to the first node. So we will just say first. So this one will point, this pointer will now point to first. This one now will point to first. That's the effect of this statement. We redirect this one. Instead of pointing there to B, we make it to point to A. And after that, we would redirect the second pointer. The second pointer is this one. So that is simply first dot right. First dot right is this pointer. And we want it to point to the third node containing the element C. And what is that? That is simply the third node. Recall that it is first dot right dot right. Okay, so we will just say first dot right dot right. So this is the first dot right is the second node, and then the dot right of that is the third node. So the first dot right, this one, will be pointing to this. So this one now, this pointer now, right pointer of the first node, will now point to this node, where this one is currently pointing. So this is the first statement we are to execute, and this is to redirect this pointer. And the second statement we are to execute is to redirect this pointer to point to the third node. So it takes only two pointers to be redirected so that we could remove or delete this node from the list. So what is the result now? The result now is that from the first node A, the next node is pointed by the right pointer of A, which is now C. And the left pointer of this node should also be pointing back to A, which is this one. And C points to this node containing D, and D points to C and say this is null, and that is null. So now we have removed the previous second node containing element B. Okay, although node B is still there in the memory because we did not override it or erase it. Although B is still pointing, the left pointer of B pointing to A and the right pointer of B points to C, but the reference of this doubly linked list is the first node. So from the first node, you move to the second node by following the right pointer of the first node, and you arrive to this node. So this is now considered as the second node. And when you check the left pointer of this second node, it also points back to A. Therefore, this is the second node now, and this is the first node. So B is no longer referenced, no longer visited when you traverse the list from the first node going to the last node by following the right pointers of the nodes. And even from the last node, you traverse the doubly linked list by following the left pointers. So you go to the left, you reach the second to the last node, and then you go to the left to go back to the first node. So when you traverse the list following the right pointers, you cannot visit node B anymore. And from the last to the first, you follow the left pointers, you cannot visit node B anymore. So node B is considered removed from the doubly linked list.